Welcome back. This is an Aleks homework video on distinguishing chemical and physical changes. So in this one, this could be very hard. You have to really think about this, and you actually may need a pencil to kind of figure this out on paper, but you've got, in this case, some kind of a chemical. I would think it's probably representing carbon dioxide. Black normally is carbon. Red is usually oxygen, so you have one carbon and two oxygens. CO2 is carbon dioxide. And they're asking you, could these change? And if they could they change, say this could change into this? And if it is a change, is it a chemical change or a physical change? So back to definitions. A physical change doesn't change the stuff. It doesn't change into a different substance with different properties. So, for instance, if I take water and freeze it into ice, that ice is still water. It's just frozen water. If I take water and I boil it into steam, it's still water. It's just gaseous water. So, at the end of the situation, you've got the same stuff that you started with. So, if I take a big rock and break it into two small rocks, that's a physical change. It's not something different. But if you take that rock and you put an acid on it and it bubbles away and you've changed it from something into something else, then that's a chemical change. So a chemical change is the same as having a chemical reaction. Can you have a chemical reaction in order to make it? Then that's a chemical change. Is it the same stuff you started with? Then it's a physical change. Okay? So, for instance, let's look at change 2. There's 12 of these guys. There's 12 of these guys. They're the same. It's just that this is more orderly. So this would represent, say, a solid. This is more haphazard. So this would represent, say, a liquid or a gas, something like that, more random. So you've still got the same stuff. So this is possible. You can easily possible. If I would remove some energy from this, it would all be very orderly. If I gain energy, then I make it more hyper and it bops around. So this would be possible, but it's not something new, so it's not a chemical change. This one would be a physical change. Okay, so you're looking for something that's the same, then it's a physical change. Now these guys are not physical changes. I don't know if they can happen or not. They're not physical changes because they look different. This has two reds connected together and one black and one red connected together. So I don't know. Let's see. First of all, we need to see, is it possible? So let's break apart this. Let's say I've got a black, okay, and a red and a red. So can I make this? Well, what is this? It's a black and a red. So I've got a black and a red. Oops, that's a red. Black and red. And then if I had two of them, a black and red and a black and red. Let me scratch that out. Black and red. Where's the other two reds that used to belong here? So this one had one and the other one had one. They could meet together and make two reds. So this could break apart. Now there's 12 of these. That means I'd have to have, if this is what's happened, I'd have to break this into 24 of these plus 12 of these. So how many do I have? 1, 2. No, I'm wrong. This is there's 12 of these, so there would be 12 of these, and then there would be 6 of these because that'd be half. I'd need to steal one from every two and make its own. So do I have 6 reds? 1, 2, 3, 4, 5, 6. That's good. Do I have 12 of the others? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that is possible. I could break it apart that way, but it's something new, so that's a chemical change. What about these guys? I've got the black and red, but where did the other reds go? Do you see? Matter can't disappear when you do a chemical reaction. You're going to have the same amount of stuff at the beginning as the end. Well, I've got the carbon in one of the oxygens, but I don't have the other oxygen. So somehow this oxygen just disappeared, which is impossible. So that can't change into that. I would have to have those leftover reds do something, combine with something. Okay, so complicated, but the pictures I think actually help me.